alternating series. What is an alternating series? So for example, this series, the sum n equals 1 to infinity of minus 1 to the n plus 1 over n, is an example of an alternating series. Chris, what does that even mean? Let me write down some of the terms that I think will be a little bit clearer. So if I plug in n equals 1, I get negative 1 squared, which is 1 over 1. So 1 over 1. When I plug in n equals 2, I get negative 1 cubed over 2. That's negative 1 over 2, so minus a half. When I plug in n equals 3, that's negative 1 to the 4th over 3. That's 1 over 3. That's plus a third. When I plug in n equals 4, I get negative 1 to the 5th, which is negative 1 over 4, so minus a fourth. When I plug in n equals 5, I get negative 1 to the 6th over 5. That's 1 over 5, so plus a fifth. When I plug in n equals 6, I get negative 1 to the 7th over 6. So that's just negative 1 over 6, so minus a sixth. And then it's going to keep on going like that. But I'm flip-flopping between these two colors. I'm alternating signs, right? I'm adding, subtracting, adding, subtracting, adding, subtracting. That's an alternating series. So that's what I mean by alternating. Well, here's a precise definition. The series, sum a sub n goes from 1 to infinity, is called an alternating series if a sub n is equal to negative 1 to the nth power times b sub m, and all the b sub n are the same sign. So maybe the b sub n sequence is, say, all positive, and then a sub n has this term here times a positive sequence. Well, this term is what makes the signs, the SIGNs, flip-flop back and forth. Well, here's a bit of a warning. Not every series which has both positive and negative terms is an alternating series. For example, this series, the sum n goes from 1 to infinity of minus 1 to the n times sine n over n. This is not an alternating series. I mean, yes, it's got the minus 1 to the n here, but the sine of n also introduces its own quite complicated pattern of positive and negative terms. So this is a series, some of the terms are positive, some of the terms are negative, but it's not alternating, right? This is not an alternating series. Cook up other examples. Sum n goes from 1 to infinity, say minus 1 to the n times n plus 1 over 2. So that's all in the exponent there, n times n plus 1 over 2, say all over n. This is also not an alternating series, and it's still got a minus 1 there to raise to some power, but the power is a little bit more complicated. N times n plus 1 over 2. The terms are, some of them are going to be positive, some are going to be negative, but they're not flip-flopping in sign, in SIGN back and forth. In contrast, here's an example that is an alternating series. The sum n goes from 1 to infinity, say of minus 1 to the n times sine squared n over n. Sine squared n, this turns out to always be positive, right? The n is positive here, at minus 1 to the n. This is the only thing that's affecting the SIGN of this term, and this does indeed then flip-flop back and forth between negative, positive, negative, positive, negative, positive. This is an alternating series.